All right, so here are several questions, Foundations of Math and Pre-Calculus 10. This is Chapter 2 review questions. So I'm just going to set these questions up for you, get the diagrams drawn, get you kind of off on 16, 19, and 23. So it says this, in 16, it says a ship is sailing off the west shore of Hudson Bay. At a certain point, the ship is 4.5 kilometers due east of the town of Arviat. Okay, so it's due east. So what are our directions? Never eat shredded wheat. Okay, northeast, southwest. So a ship, at a certain point, a ship is 4.5 kilometers due east. Okay, so it's east of, right here. So here's A. It is 4.5 kilometers due east. All right. The ship then sails due north. Okay, so I'm going to have to bring this down a little bit because we're sailing north. The ship then sails north until the angle between the path of the ship and the line of sight to the town is 48.5. So due north, okay, until right about here, when the angle between the path, the ship's path right here, and the line of sight to the town is 48.5. Now, because we're due east and due north, we have a right triangle situation. So once again, this is what you're given. 4.5 kilometers here and 48.5 degrees here. So the question is, state the, how far is the ship from Arviat? So we're looking for this one here. How far is this length from here to there? Okay? So that's how you start number 16. And I guess if we went one more step, we're looking at an angle with its opposite side, and this is the what side of a right triangle? Opposite and hypotenuse. So which trig function has O and H with it? Yep, sine. So, ka, toa. So use the sine trig ratio. Okay, so that's the setup for 16. You can go ahead and finish that one if you had trouble with it. I am going to set up 19 though, so let's move to 19 here now. I had a question about 19. Okay, so 19 says this. In Italy, the Leaning Tower of Pisa currently leans 13 feet off vertical. Okay, so watch this very carefully. For those of you that are drawing this, here would be vertical. I'm going to draw the vertical right about here. And this is where the edge of the tower should be, but it's 13 feet off. So that's 13 feet. That's a lot. They've actually dug down kind of underneath it and around it and stabilized it so that it won't fall over. They're not going to straighten it because there's so much history. And apparently Galileo dropped stuff off the edge of the tower, and he did a bunch of measurements and studying different things. So there's a lot of history to this tower. So they've braced it so that it won't fall over, but they're not going to straighten it because it's the Leaning Tower of Pisa. Okay, so 13 feet. The tower is 183 feet. So 183 is the total height here from wherever the ground would be. What is the angle of inclination to the nearest tenth of a degree? Okay, so now remember, inclination. This is very, very, very important. Some of you are thinking, okay, I need to find this angle here. Oops, it's a bad line. But you need to find this angle, and you're saying, I need to find this angle right here. No, that's not the angle of inclination. Let me redraw this not to scale. This is 13. This is 183. It's sort of an 8. You're not looking for this angle. We're not. We're looking for the angle of inclination of the tower. So inclination is always from vertical. I'm looking for this angle. That's the angle we're looking for. So you can find this angle. Absolutely. You can find that angle first. That's how you do it. And then you subtract it from 90 to get the angle that you're looking for. So that's why it's important to draw a diagram. It's important to read carefully. And remember, angle of inclination is always from the horizontal up. Always from the horizontal up. And it's always an acute angle. It's never this one. So it would never be an obtuse angle greater than 90, the angle of inclination. Because you think about it from straight horizontal up, okay, that's an angle of inclination, so is this. But as soon as you go above 90, way over here, that's not an angle of inclination anymore. The angle of inclination would be now this way going up. So it's always an acute angle. So it's not this one here at all. It's not that one. Okay? So that's 19. I'll let you finish 19. And here's 23. So another tough one was 23. A fire ranger is at the top of a 90-foot observation tower. There's 90 feet. There's the tower. Okay. She observes smoke due east at an angle of depression of 5 degrees. So they got the diagram for you. She's looking here at a fire, and the angle of depression, now remember the angle of depression is also from horizontal, but instead of inclining up, it's declining down, depression. Okay, 5 degrees. And due west, so that's the exact opposite way. We're just looking at, a two-dimensional diagram here, has an angle of depression of 4. Okay, which fire is further away? Just out of curiosity here, which fire is further away? The one that has the greater angle of depression or the lesser angle of depression? And you can kind of see from the diagram. Yeah, so if you're looking down, if you have to look way down here, the fire is close, you have a large angle of depression. If you have to look way into the distance, you have a small angle of depression. So the smaller the angle of depression, the further away. So that means that this is going to, this length right here is going to be greater than this length. But it says how far apart are the fires? Oh, okay. So we need to find the total from here all the way to here. Okay? So it looks like we're going to have to solve 2 separate problems. We're going to have to solve for this one here and for this one here. And then add them up. Okay? And what do you know? You know that this is 86 degrees right here. And you know that this is 85 degrees right here. So you've got your 2 triangles. One looks like this with 86 degrees. The other one looks like this, 85 degrees. And this is 90 for both, right? 90. So how do we find x here? Well, if this is the angle, we have opposite. This x is opposite. And this is the what? Hypotenuse or the adjacent? Which one is it? Yeah, opposite and adjacent. So what trig function goes with that? That's tan, right? Because we have so, and we have ka, and we have toa, so katoa. So use your tan function, ratio here, and also opposite, adjacent, use your tan here, add x plus y. Okay? All right. So that's kind of the start to those 3 questions. I'll give you the answers. I'll give you the answers to these questions in a few minutes, and you can double check your work, see how you did. Okay, so we did look back at 19 here. Good job in catching that. The tower, it says the tower is 183 feet tall, and because it's on an angle, in this diagram, the 183 feet should be here. Yeah, that's totally true. So this is 183 feet. We still can find this angle right here and then subtract it. So yeah, good job on that one. That was my mistake. The answer to number 16 here should be 6.0 kilometers. 6.0 kilometers. All right, the answer to number 19, this angle here, looks like it should be 85.9 degrees to the nearest tenth. And the answer to number 23, x plus y here, should be 2,316 feet, looks like. 2316 feet. Okay, so make sure you show your work here, but that's what your answer should look like there. Okay.